Hello everyone. In last video, we have discussed about change of velocity and a rate of change of velocity. The rate of change of velocity we have discussed for uniform motion. We know that change in velocity is equal to final velocity minus initial velocity for the object. And during the uniform motion of an object along a straight line, the velocity remains constant with respect to time. So through that graph, the uniform motion graph we have discussed, and we came to know that change in velocity of the object for any time interval is zero. So this is regarding with the uniform motion. Now, if we consider non-uniform motion, as you can see in this graph, even these graphs also we have discussed earlier. Here we have taken four time intervals, time interval 1, 2, 3, 4. And for these time intervals, time interval 1, 2, 3, 4, if I take corresponding change in displacement ds1, ds2, ds3 and ds4, what we can observe is ds1 is has the smallest magnitude and ds4 has the highest magnitude. From ds1 in increasing order, the displacement has increased. So displacement is increasing from ds1 till ds4. Similarly in this graph also, so this graph is increasing non-uniform motion and this graph is a decreasing non-uniform motion. Here also ds1, ds2, ds3, ds4 are the corresponding change displacement of the corresponding time interval. We know that velocity is equal to change in displacement divided by time interval. Change in displacement we have taken as a ds and time interval as a dt. Now this is regarding with the velocity. Now if I consider change in velocity, obvious change in velocity will be proportional to change in this ratio ds divided by dt. Now if I look to these graphs and if I take the ratio of ds by dt in any one of these graphs, suppose if I consider for this graph where increasing non-uniform motion is there, for suppose first time interval if I take the ratio ds1 divided by dt, that quantity, and for the second time interval ds2 divided by dt, if I take that ratio, both the ratios are not same. So ds divided by dt ratio for every time interval it is different. As like in uniform motion, it is not same. And here ds1 to ds4 change in displacement value is increasing. So here obvious as there is change in ds by dt ratio for interval to intervals, there will be change in velocity. Like in uniform motion, the ratio ds by dt is not constant here. As there is change in ds by dt for this non-uniform motions, change in velocity will exist. So for non-uniform motion, velocity is varies with time. One more thing, in uniform motion, we have a straight line which is passing through the origin and the slope of that straight line was constant for any time interval. But here the curve is not straight line. This curve is a non-linear curve. And here the velocity is varying with respect to time. Velocity is not constant. So the change in velocity of the object for any time interval if you take, then it will be a non-zero value. Like in uniform motion, the change in velocity of the object won't be zero, right? So for non-uniform motion, change in velocity of the object for any time interval, it is a non-zero value. But same for uniform motion, change in velocity of the object for any time interval if you take, that value will be zero. So this is regarding with the change in velocity and rate of change of velocity for uniform motion and non-uniform motion. Thank you.